Hi.
There.
Good.
Thank you.
Awesome. Thank you for coming to my talk. So this is going to be like super quick, super short, informal, but fun, I hope, because lunch is right after this. So I'm going to let you go fast. So my name is Veronica Lopez. I'm a senior software engineer. I have a lot of experience in distributed systems, like real distributed systems and Kubernetes distributed systems. And I don't know, like it has come, like my experience has come out of necessity, like rather than me wanting to be a distributed systems engineer. So it is very important. I always mention this in my talks. And for those of you who have already seen or heard me speak, please don't roll your eyes, but the very fact that I am Mexican and I used to work in Latin American companies, like big companies, and the type of systems that we have to deal with are very different from like American companies. Our constraints are very different, and even though like right now it has started to change, it was very common that your bosses or like the founders or the immediate person that had to approve your budget were not technical. They are like people who like technology and started companies for a reason, but they aren't usually like the most technical person around. So what does this mean? It has a lot of advantages, but also a lot of disadvantages, because like for every single technical decision that you have to make, let it be a trade-off or that you need money to get a new server, a new cluster, a new license for something, you really have to justify everything. Like, because for them, it's just like money that maybe another person could be not spending, and you really have to justify every single piece of it. Therefore, and that's in like the best case scenario. In the worst case scenario, you don't have to justify anything because there's no money at all, so there are no possibilities. So with this in mind, you have to be very, very resourceful. And the reason why I'm telling you this is because all of these approaches make sense with what I'm about to present and the conclusion of it all. So even if now I have been working in American environments with a lot of money in big companies and they say yes to everything that I want, well, you want to be resourceful still, right? Like, because the more resources you have, the more resources you have to manage. So it's not even an economical problem anymore, but it's like you don't want to shoot yourself in the foot. So whatever. The point is that you have to learn to be very resourceful, and that's why yesterday someone was telling me that for some reason that they were surprised that for some reason the Elixir community, the Beam community, was very big in Latin America, which is definitely not a tech hub. Like Mexico or Colombia or Argentina are not like the biggest tech hubs to be known for. So, however, Elixir being like not the most big popular language around is very popular down there. And I think, like personally, all of this is like my opinions. So please take them with a grain of salt. I'm not trying to say this as law, but with all my experience, this is my opinion. So in my opinion, all of these tools, the Beam, are very popular down there because for the same reasons that I told you, that it works and it is very efficient, and with very little resources, you don't have to, like, the same amount of code works distributedly, is that a word? Distributedly in very little resource, with very little like infrastructure, as opposed, I don't know, other type of languages that are more bloated, stuff like that. So, sorry. So with that context in mind, everything that I have learned, that I have needed, has to be with all that improvement, performance, and very little resources in mind. So I used to be a physicist, and I love academia and all that, but I didn't have the courage or the persistence to spend time there. So I transitioned into the industry, and I started getting money out of it, so I didn't want to go back. But the thing is that I love it. So I have always had like a healthy balance of like reading the paper and then going with my peers and tell them like, I read this on a paper, can we implement it? Or I know this person who might help us, and the other way around too. And I don't know if you have ever seen like that there are papers that from the 70s, the small talk, stuff like that, that nobody ever uses. And then people from Kubernetes tell us that they just invented the newest technology. Yeah. So, and the other way happens as well. Like a lot of very fancy stuff are in papers, but then nobody wants or needs to implement. So it has been a very interesting discipline being in distributed systems, because it is, I think that it is one of the single like areas in software engineering that still has that like beauty, for me at least, of collaboration between both worlds, and that still produces like new stuff, like new content, and that both of the areas can benefit from each other, as opposed like, I don't know, like web development or things that are more just like closer to the product. So I used to work at Red Hat via CoreOS, the acquisition of CoreOS. So with there we used to build an enterprise Kubernetes distribution. And etcd, I don't know if you have ever heard about etcd, our distributed key value store. So a lot of the problems that we used to solve, even if we were like part of Red Hat in the huge company, many times we were not totally product oriented. Like our workflows were research and, you know, like thinking before coding, what everybody tells you, but like put into reality. So that was really fun and gave me like a lot of perspective. So now on the personal side, I prefer the Beam, Elixir, and Erlang. But unfortunately, for the type of problems that I have been trying to solve in the industry, nobody wants to use them. And instead, like especially in the area in Silicon Valley, everybody is crazy about Go. And there's usually like this discrepancy about like whether it's worth it to learn the Beam, OTP, and all that when you have Go, or Rust, or all those kind of things. And now, the very thing that I think that I can contribute a lot and that I can talk to you about, not so much teach you, but like condense my experience in a unique way, is that since I have loved Elixir for a very long time, but have had to work with Go for professional reasons, is that as soon as I landed in the Kubernetes community and started looking and listening to people like, hey, we came up with this new thing. And I was like, that sounds like Erlang. And it is not like completely new, you know? And maybe the implementations are like more friendly or like easier to use or not so obscure. And obviously having like a support from a company such as Google, it definitely makes a difference. So, well, with all of this in mind, I want to tell you all the things that, and all of this is relevant because Kubernetes is one of the most visible projects built with Go. So people assume that as well, like Docker or CoreOS stuff like etcd, that maybe the way that you have to work with this stuff is only with Go, and the best way to do it is just having like the same level of complexity and not having a lot of diversity, technologically speaking. And that may be true, but I will tell you how and why it makes sense to have both. So I don't know why this is not changing. May I have some help? It's there, but it doesn't.
Do you go to the presentation or do you have the presentation?
I do. Here.
Go plug it back in.
we go. Oh, yeah, it's working, yeah. So actually, all the first part was this. I'm sorry that you didn't get to see it live, but and so everything that I told you is there, and is there for a reason, not just like to brag about the things that I have done. So particularly before joining Chorus, I had no Kubernetes experience. It was like out of necessity because like the company, like I was hired as a distributed systems engineer, and then everybody started like contributing to our Kubernetes distribution, and it was sort of like fate. So with this, I told you that I started seeing like many similarities. Like they were like, hey, it's the first tool ever that gives you fault tolerance. And I was just like, I'm not sure. And at the same time, I was like, maybe I am missing something. To be honest, I am very humble in that way. So being surrounded by such like technical people and very smart people, the smartest people that I have ever worked with, I was like, they cannot be wrong. I mean, there must be something that I'm missing, right? But it turns out I didn't. It turns out that they were missing some context. And it is something that I have seen repeatedly, like in other communities, especially the Go community, with which the Elixir community like competes for users for the same type of problems. A lot of people are not aware of the capabilities of the Beam, and it's a little bit sad because there are a lot of redundancies that are not productive for anyone. So the structure of my little talk is like the what, the why, and the how. So what really is Kubernetes? Then why it might make sense for you to use it or not, but now with an informed decision, and how to do it. I'm not like taking any time to do any demos or any like processes because there are a lot of online. But the difference with this is that all the tutorials and all the workflows that are online show you how to do it, but they don't tell you why should you do it or why shouldn't you do it, and that's okay. I mean, that's not the purpose of tutorials. It's just like to getting things done. Okay, so in my experience, many people associate like the Kubernetes experience with DevOps. In my case, I don't have a lot of experience in implementing actual Kubernetes. Like my job is to write Kubernetes. So that is a very different thing. So I must warn you about this because there are many useful cases out there, like from people from DevOps, and having like amazing war stories that I don't because I don't work in that space. Like one thing is to build a fancy tool, and another thing is to actually use it. So I have like very little experience actually implementing it, but since like on the good side of that is that since I got to build like stuff that I'm going to talk to you about like in a second, I built stuff from the very beginning, from the ground up, and with all the patterns and design things in mind, I can tell you why it makes sense and when. So in your case, I guess, if you're here, is because you might be, who here uses Kubernetes with Elixir already? And who is happy doing it? Okay. And who would like to? Okay, awesome. And I don't know, why are you here? No. So there are many misconceptions. Okay, so here's my point that there are many demos online. So I'm going to focus on the state of the tools and why and when it makes sense to use them. And well, if you have any questions about any processes or tutorials, just ping me either on Twitter or whatever, and I'll send you the best tutorial that I can find about integration and stuff like that. So first of all is like the misconceptions. So what is Kubernetes according to like what people sell nowadays? Like fault tolerance, resilience, consistent upgrades, rolling updates, high availability, isolation of processes, blah, 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 blah. And then we have all that, and like the Beam community is like, but I already have all of that. I don't need like an added layer of complexity to have this. So, and then you can be certified Kubernetes. that we don't even know what that means. So like months ago, they announced that the CNCF, that is the Cloud Native Foundation, announced that Kubernetes had graduated from the Cloud Native Foundation, and we were like, what does that mean? And still we don't know. But okay, so what Kubernetes really is that a container orchestrator, and containers are well suited for everybody. It doesn't matter if you like Go, Elixir, Java, or JavaScript. Like, containers are useful for many, many things, and if you're not familiar with them, just get familiar with them because they're very useful. So once you have, containers can be used individually, or if you're really good at it or it's your only job, you can orchestrate them manually. But once you have a lot of containers and a lot of responsibilities, the best thing to do is use an orchestrator. There are many orchestrators out there, but the standard nowadays and the community that has more tools is Kubernetes. It is also a deployment and delivery tool. That sounds boring and cheap, and that's the point. If for DevOps or think about DevOps as an organizational practice or as a job. The main selling point of our Kubernetes should be delivery and deployment, but that doesn't sound sexy as resilience and fault tolerance. So all this improves productivity. And everybody wants that. Even Elixir people wants to improve productivity. Also, what Kubernetes is a huge API, huge API that you can use or customize as much as you want. This means that you can just use it to literally schedule pods that are the minimal, how do you say that? The minimal unit for Kubernetes. Or you can schedule very, very complex operations as much as you like, independently from the logical layer of your applications. So that's another thing. A lot of people that tell me so should I use both a Beam language and Kubernetes, or it doesn't make sense? Because they overlay in power and processes. And then I have seen other people telling those people hey, you're a dork. One is a tool and another one is a language. It's yeah, everybody knows that. But the objective of both, at least on the marketing side, is basically the same. So everybody told us, let's go a little bit behind, what Kubernetes sells, there's all of this. What Kubernetes is, according to my experience building it, and it's nobody told me that, right? And so let's remember, first of all, that Kubernetes is a product. It's open source and it's widely used for free, but a lot of people make a lot of money out of it. And even though it has been donated to the CNCF, it was mostly backed by Google. So yeah, a lot of companies from Amazon, Red Hat, Microsoft, everybody wants a piece of it. So of course, they have to sell the experience. So I always say, it's a marketing strategy that met language deficiencies or poor language design. And well, the side effects are all of this. Are all of this. But this, my main point from out of this is that even though everywhere that you take a look about Kubernetes, you will find this. And you might not need that as an Elixir user or Erlang user or as a good programmer, but in any language. But this is really what it is, a more boring abstraction, and it's fine. So we have the concept versus the reality. In my experience, Kubernetes is not even heavily used the way it is advertised. Let's say that, as I say, it's a secondary effect, a side effect, to have resilient systems, and everybody wants that. But if you take a look around, like in the job postings on LinkedIn, Stack Overflow, whatever, everybody wants to use Kubernetes for delivery, and not for resilience and fault tolerance and all that. So the more resilient and fault tolerant systems come as a consequence. But in practice, everybody uses it only for deployment and productivity goals, which is like even the fancy people of Elixir need that. And well, spoiler alert, Kubernetes is not even as good as the Beam to do all those things that they advertise. But they're really good at other things. So the first approach is testing. And everybody needs testing. So I really liked Fred's talk yesterday about a property-based testing for Elixir. Well, I don't know a lot about that part, but it makes total sense. So once you design your system with property-based testing, I'm going to show you the workflow. Oh, well, no. the workflow would be like, ideally, it would be, okay, you finish your application, your system, and then you use distillery, ideally, to create the release, the Elixir release, and then you use the property-based testing techniques, and you containerize all that. So a great approach for Kubernetes and Elixir, not just like using it as any other tool or with any other tool, is like there's a trend in distributed systems that I don't know if you're familiar with it or if you support it, like testing in production, because like the principle behind it is that distributed systems are so complex that not only in the nodes or the tools that they use, but its interconnections. It's like the devil is in the details. So if you just have like a testing environment that doesn't include the possible interconnections, then it's like a little bit not worth it. So the ideal thing to do, what people say is that the ideal thing to do is to test in production because that implies that you're really seeing what it looks like real life failures. So in order to see all of this, and with any approach that you like let's say property-based, the Elixir way, you can containerize all that. So let's say that for distributed teams or for people that need continuous development and continuous integration, like this approach is fantastic. It saves a lot of time because you containerize all your tests, all your main points that you really need. And then every time that you, let's say, that you are working with a CI/CD or like GitLab or something like that, all you have to do is send a testing suite, you containerize it, and you test everything against that. So it takes seconds. Like it's very, very useful. Even if you don't containerize the rest of your environment, even if you don't have like 100% container approach architecture. Then the tooling. This is my favorite part. So I'm just taking like 5 extra minutes because of the delay in the slides. But the tooling, once you containerize and orchestrate your Elixir things, your systems or application, it's much more than systems that don't crash because you already have that. So there are some things called operators that is actually like the unsung hero in the Kubernetes community, the operators. So once you start using Kubernetes, someone here is familiar with operators in Kubernetes? Okay, so what usually happens is that people adopt Kubernetes, and once they're there, they discover the notion of operators. But I think that it should be the other way around, because they're like, an operator is basically anything that can be automated inside Kubernetes, and thanks to the API. And so it has become so popular that the new name for operators is Kubernetes native applications. It's like the fancy name. Exactly. But it is really, really powerful. And so at Red Hat, I was in the team building an operator framework, something called the operator framework, that basically allows you to automate anything that you want inside Kubernetes. So with this in mind, you could create your own operator to automate your Elixir stuff, but complying with the API, with the Kubernetes API. Therefore, you have like two behaviors that complement each other, that don't overlap in power, that don't overlap in resiliency and whatever that you need. But then you have the two layers of complexity that you may want, like the application layer that is resilient, fault tolerant, that it heals itself, whatever. But at the next level is the infrastructure part, that it doesn't matter how efficient your application is or your system is, like you still have to deploy it somewhere. And it doesn't matter how self-healing, how performant it is, if your infrastructure is not the ideal one. So there, in that use case, in that use scenario, you can like make the most out of both. Like you can have the self-healing powers of the infrastructure and deployment and the self-healing powers at the application layer. So that's amazing. And well, just a quick, actually yesterday or 2 days ago, well, very recently, I just had to add this slide. There is a website called operatorhub.io that is basically anyone can create an operator. You don't even need to use the operator framework to create an operator. I recommend that you read more about this because this deserves another whole talk. But the principle behind this is like you can automate anything inside Kubernetes. Like it could also be like Elixir-based properties if you'd like. I don't know about any operator like based on Elixir right now, but that doesn't mean that you cannot do one. Right. It's also because of the adoption space right now. But I think it's just a matter of time. So the concept of operator, we brought it, we sort of created it back in CoreOS back in the day to automate things that we needed, like Prometheus, etcd, stuff like that. Are you familiar with Prometheus, for example? Like Prometheus would be like a great case scenario to use inside Kubernetes for Elixir. So a lot of stuff that you can get benefits from by using Prometheus, by automating a lot of repetitive tasks. You just containerize everything, you orchestrate them, and you put the operator on top of it, and it runs like smoothly. You don't have to do the repetitive manual tasks every single time. So, well, we created the concept of operators back in the day, and then people in the Kubernetes space liked it a lot, and they started doing their own operators. But it was like, since Kubernetes is such a huge API, everybody sort of interprets it like the way they want. So when people created an operator, it was basically like the way they understood it. So even if they do what they have to do, that is automate the tasks, sometimes it was not the most optimal way. So we came up with a humble approach, a humble but opinionated approach of how to do these operators. You can still do them like on your own and based on your own needs, but we did a framework so that to make sure that when you create your own operator, it meets the requirements, like the bare minimum requirements to work. And now they came up with this website where it's like a catalog of like certified operators, because there are like hundreds out there, like in GitHub. But here is like the vetted catalog of the ones that follow all the rules. And for example, here we have the Kafka one, the Prometheus one, the etcd one, a lot of automated things that make your life easier. And so with this approach in mind, and just to sum it all up, with this approach in mind, this is how you can really use Kubernetes with Elixir. Like not taking it as your only resiliency tool because Elixir already does that. Not taking it as your fault tolerance like nugget because Elixir already does that. It's like to go a little bit further. Like there are many, many, many tools that are not usually advertised, like when you Google how to use Kubernetes, right? These things usually don't come like in the first results. So I wanted to invite you to, because a lot of people ask me that, and since the beginning of the talk, I told you that I love the Beam community and any opportunity to work with it. But like out of necessity, I have had to work more with Go and Kubernetes, and I have seen so many similarities, and I hate like for the sake of the community or the industry or knowledge of everybody, that there are so many things that get repeated, like because people don't listen. Like there are two tools for different stuff, and they're being used for the same stuff. But we can like extend the capabilities of one thanks to another. So I hope that all of the topics here deserve their own talk. But I just wanted to give like a quick introduction of how to give more power to your stuff. And if you, just to finish, if you decide to go with a Kubernetes option, I recommend that you do it with a managed Kubernetes one. It can be Amazon, DigitalOcean, which is my favorite. I don't get paid for that. OpenShift. I don't know, but I think that that's the best way to go so that you can be more productive rather than learning yet another tool, because that would be like counterproductive. And if you have any questions, please let me know. And if you're interested in creating an operator, I can help you with that. Thank you very much.
Thank you.